Welcome to our channel. Today we are discussing about what is the principle of transmissibility. So let's jump on our first slide. A force can be applied anywhere along its line of action. Its effect on the body remains the same, only applicable to three coordinates. What does it mean? जब आप किसी भी बॉडी पर फोर्स अप्लाई करते हैं और वो फोर्स के जो पॉइंट्स है वो इट्स उसके लाइन ऑफ एक्शन पे रहेंगे, तो वो जो बॉडी पर जो इफेक्ट है वो दोनों भी पॉइंट्स का सेम रहेगा और ये बस जो रिक बॉडीज है उन पर अप्लाई होने वाला है. इट्स मीन्स दैट अगर आप एक रबर लेते हो, फिर रबर स्ट्रेच करोगे तो वो स्ट्रेच करने के बाद वो उसका शेप चेंज करेगा. मीन्स ये रबर पे अप्लाई नहीं हुआ जस्ट फॉर डीप बॉडीज एंड सॉलिड बॉडीज. लेट्स जंप ऑन नेक्स्ट स्लाइड. So let's understand this principle through a simple diagram where here is the force F at different points on the same line. A force can be applied anywhere on its line of action and still have the same effect on the body. Let's understand this. Here is point A, here is point B. If you applied force from this point A, it will be move the object forward. If you applied force from this point B, it will be obviously move the object forward. Why this happening? Because these both A and B point are on its straight line of action. That's why the force applied on this object still produce the same effect. Simple. Okay, let's jump on some real life examples of principle of transmissibility. First is pushing a door at different heights. Okay, when you push the door from its handle and when you push door from its top, it will be still gives the same effect. The effect will be the door will closes. That's mean this point and this point, when you close door, the both points are having in its line of action, in its straight line of action. That's why this will produce the same effect that the door will closes. Easy. You perform this task daily. Opening door, closing door. You can try it while closing from the top of it or below of it or from its handle. The door will close or open directly. Here is our second example, that is pulling a card with rope. Okay, let's understand this. This is man, this is card, this is force applying to it. Okay, here if you grab the rope from this point, it will be goes forward. If you grab rope from this point, it will go forward. Or if you grab rope from this point, obviously it will move to forward. Okay, why this is happening? Because this is in its line of action, its straight line of action. That's why the card, when you grab the rope from different points, but that points are in a straight line of action, that's why the car will be moved forward. Easy example. Let's jump on the condition for using the principle of transmissibility, only valid for weak bodies. It's important to understand that the principle of transmissibility is only valid for weak bodies, objects that do not deform under the force. Like rubber band, it will be deformed under the force. That's why it's not applicable for rubber band. Not valid for deformable or elastic material. In the real world, many materials like rubber or springs are flexible or elastic. For those, this principle doesn't apply because shifting the force can change how the material bends or stretches. It can create different internal stresses depending on where the force is applied. Not used for internal stress analysis, doesn't change net external effect. So This principle is mainly useful when we are analyzing external effects like movement or reaction forces in ideal rig body conditions. Always keep this limitation in mind when applying the concept. Okay, these are some conditions for using the transmissibility. Okay, let's jump on our next slide. Why is the principle of transmissibility is important for mechanics? Simplifies force analysis, helps in drawing free body diagrams. It helps us simplify force diagrams and makes solving problems much easier, especially when dealing with equilibrium and free body diagrams. Useful in solving equilibrium problems. Since we can move force along its line of action without changing its effect, we can choose a position that makes the math simpler, like reducing the movement or aligning force more clearly. Basis of many mechanical concepts. This flexibility saves times and helps us focus on solving the real problem without worrying about where the force is applied, as long as it's on the same line. So these are points why the principle of transmissibility play important role in mechanics. So let's quick recap what we learned about the principle of transmissibility. It tells us that a force can be applied anywhere along its line of action and it will still have the same effect on the body. We saw real life examples like pushing a door, pulling a cart, all showing this principle in action. But remember, this only works for deep bodies. It doesn't apply the flexible or elastic materials where internal stresses matter. And in engineering, this principle helps simplify problems and in engineering this principle helps simplify problems and make force analysis much easier. That's why the principle of transmissibility is such a valuable concept in mechanics. Thank you for giving us chance to present this topic.